Okay, so here we are in 4.7 part 2. This is where we left off in part 1. We talked about how, okay, we need to restrict the domain for these trig functions in order for them to be a one-to-one function, so that we can talk about inverse functions, because we said here, in order for the inverse to exist, the function needs to be one-to-one. And it's one-to-one if it passes the vertical and horizontal line test. And we saw that it originally did not pass the horizontal line test, but it does if we only look at a portion of it by restricting the domain. Okay, so now we're going to take a look at each of the three inverse trig functions. Okay, so let's start with the inverse sine function. Okay, so f of x equals sine x for x between negative pi over 2 and pi over 2. Okay, so this is very important that you really understand that it's being restricted, and that you understand that it's being restricted between these two numbers over here. Okay, so what this is saying is that the domain of this function um, is going to be from negative pi over 2 to pi over 2. Okay, so that means that if I ever plug in any angles, I can only pick angles that are between negative pi over 2 and pi over 2. So like from negative 90 to positive 90 degrees, right? Which means that I can't use 135 degrees because that's outside of our domain. I can't even use 180 degrees. That's outside of our domain. We can only go from negative pi over 2, which is the same as negative 90 degrees, and anything from there all the way up to positive 90. So you can use 30, 45, 70, 60, negative 20, negative 80, but you can't use like negative 91. Okay. All right. So you can only go between these two angles when you plug in here. Okay. Our range is still going to be the same. The highest it's going to be is 1. The smallest it will be is negative 1. Okay. So when we talk about the inverse, so here when we talk about the inverse trig functions, we actually have two notations for it. So we can do sine inverse x. We can use that notation. Or we use this one over here, arcsin. So you will see your book use both of these. So just make sure you're familiar with both of these notations, and make sure on your calculator you can find one of these. Okay. So here, if this is the inverse, if you recall in the first video, we said that inverse functions interchange the x and y values, right? And the x values are the domain, y values are the range. So if this is the inverse trig function, then it's going to interchange these, so that now here your domain is not going to be negative pi over 2 to pi over 2, but it's actually going to be negative 1 to 1. And then our range will be from negative pi over 2 to pi over 2. These are our y values. These are our results. Okay, these are our results. Okay, when we plug something in, our result up here will be somewhere a number from negative 1 to 1. If I plug something in here, our result will be an angle that's between negative pi over 2 and pi over 2. Okay, so that's what this means. And it's important that you really understand this when we start evaluating sine inverse or arcsin. Okay, so this means answers are angles between negative pi over 2, and pi over 2. Okay? So whenever they ask you to evaluate this, we better not see like an answer like, oh, 175 degrees. That's outside of your range of answers. Okay. All right. Okay, so let's take a look at some examples. And let's do the ones that we have memorized. All right, so let's evaluate in radians. So our answer has to be in radians and without using a calculator. Okay, which means I'm going to give you some that you already have memorized. Okay, so let's take a look at these here. Sine inverse. So we're going to take a look at sine inverse of square root 3 over 2. You have that one memorized. And we'll take a look at sine inverse of negative 1/2. And we'll take a look at arcsin, means the same thing, arcsin, sine inverse, negative square root 2 over 2. Let me continue over here. Arcsin 0, sine inverse of negative 1, and arcsine of 1. Okay, so remember the inverse trig functions, these guys here, your answers are going to be angles, okay? And they have to be angles between negative pi over 2 and pi over 2, okay? And so here, you have to guess the angle such that the sine of it is square root 3 over 2. So you should have those memorized. If you don't have them memorized, then this part is going to be a little confusing. Okay, so what angle is sine square root 3 over 2? That would be 60 degrees, which is pi over 3. Okay? And you do that for all of these. Okay? So sine inverse, negative 1/2. So it's not going to be 30 degrees. It's not going to be pi over 6. It's going to be negative pi over 6. Okay? And then arcsine of negative square root 2 over 2. So that's going to be 45 degrees, which is pi over 4, right? But not positive pi over 4. It has to be negative pi over 4. Because sine of positive pi over 4 is positive square root 2 over 2. Okay? All right, arcsine 0. When is sine 0? At 0 radians. Okay. What about sine inverse of negative 1? When is sine negative 1? That's at 270 degrees, which is negative pi over 2. And when is sine 1? So that's what it's asking. It's asking you, when is sine 1? And that happens at pi over 2, at 90 degrees. Okay? So that's how you do these here. Let's take a look at inverse cosine and inverse tangent. Okay, so inverse cosine. Okay, inverse cosine. Okay, so f of x equals cosine x. So if this is the function, and we have to restrict it for x values. This time, cosine is being restricted between 0 and pi. Very different from sine. Sine is being restricted from negative pi over 2 to pi over 2. So you need to make sure that you really pay attention to that. Okay, so we're restricting our x values to values between 0 and pi. Okay, so that means that for our original function, f of x, the domain is 0 to pi, and then the range is still the smallest number is -1, the largest number is +1. Okay, so that when we look at the inverse function, and again, we have two notations. We could use that one, or we can use the arc cosine. Okay, so it'll look like this. So again, make sure you are able to find that button on your calculator. So here, the inverse function interchanges the domain and range. So here, the domain will now be -1 to 1. And our range, our answers, our results are going to be angles that are somewhere between 0 and pi. So again, make sure you understand what this means. It means your answers when you evaluate means your answers will be angles between 0 and pi. 0 and pi this time, not like sine inverse, where your answers are angles between -pi/2 and pi/2. Okay, our answers are going to be somewhere between 0 and pi. Okay, all right, so let's take a look at some examples here. Let's go ahead and evaluate without a calculator. All right, so evaluate in radians without a calculator. Okay, all right, so let's take a look at these. I'm going to probably do a little bit more here because it's a little more involved. All right, so we're going to take a look at cosine inverse of -1, cosine inverse 0, arc cosine 1/2, arc cosine -1/2, cosine inverse -√2/2, cosine inverse √2/2, arc cosine -√3/2, and then cosine inverse of 1. Okay. Okay, so again, you have to remember that your angles have to be, your answers are going to be angles that are somewhere between 0 and pi, which means you can't have any negative angles the way we had negative angles up here. Oh, -pi/4, -pi/6. Okay, you cannot have negative answers here for cosine. Okay, so the smallest it can be is 0. Negative numbers are smaller than 0. You cannot have that. Okay. All right, so -1, cosine inverse of -1. So hopefully you have that memorized. That's at 180 degrees. So that would be the same as saying pi. Okay. 0, cosine inverse of 0. Cosine inverse of 0 is, that happens at 90 degrees or at pi/2. Okay. 1/2. When is cosine 1/2? Cosine is 1/2 at 60 degrees, which is pi/3 radians. Okay. And cosine is -1/2. You can't say -pi/3. You can't say that. For A couple of reasons. Number one, it's not true. Cosine of negative pi over 3 is not negative 1/2. Okay, so because remember, cosine are the x values, and x values are positive here. X values are positive here, but x values are negative here, and x values are negative here. So here, if we want, if we're trying to figure out what angle is cosine negative 1/2, it's not negative pi over 3. Negative pi over 3 would be right over here, and your answer would be positive. Okay, because the x values here are positive. All right, so this is where it's a little tricky, and so that's why I wanted to focus on this a little bit longer than I did with sine. Whenever you're doing the cosine inverse of a negative number, okay, whenever you're doing cosine inverse of a negative number, okay, you need to get the angle that's over here in this quadrant, because remember, your answers have to be angles that are from 0 to pi. So it's going to come from this quadrant, okay? It says right here, answers will be angles between 0 and pi. Okay, that's what that means. Okay, so when you're dealing with these cosine inverse of a negative number, you have to get that angle that's in quadrant number 2. Okay, that has that reference angle that you're thinking of. Okay, so here it should have reference angle 1/3, so it's actually 2 pi over 3. Okay, so let's take a look at this one. Cosine inverse of negative square root 2 over 2. Okay, so we know that cosine of 45 is square root 2 over 2, right? Cosine of pi over 4. But we don't want the angle that's in quadrant 1. We want the one that's over here in quadrant 2. So not 1/4, but 1/4, 2/4, 3/4 pi. Okay. This one, the positive one, that one's easy. That's straight up pi over 4. Okay. And then here, when is cosine negative square root 3 over 2? So again, we want the one that's in here. So square root 3 over 2, you might be thinking, oh, 30 degrees or pi over 6. But we don't want the quadrant 1 answer. We want the quadrant 2 answer. Okay, so not pi over 6, but 1, 6, 2, 6, 3, 6, 4, 6, 5 pi over 6. Okay, and cosine is 1 at 0 radians. Okay, so hopefully that makes sense. Make sure, I hope you see the difference between sine and cosine. Here, your angles have to be somewhere between negative pi and pi over 2 for sine. And so that goes from here, negative pi over 2, all the way to here, pi over 2. So quadrant 1 angles and quadrant 4 angles, okay? Whereas over here for cosine inverse, your answers are coming from here, quadrant 1 angles and quadrant 2 angles for the negatives, okay? All right, let's take a look at tangent. All right, inverse tangent. All right, so inverse tangent. So if our function is f of x equals tangent x, and we restrict it for x values between negative pi over 2, this time we are restricting it between negative pi over 2 and pi over 2, similar but not the same as sine, because here we're not actually going to say, we're not including these endpoints, because if you remember on these endpoints, cosine, which is the denominator of tangent, right? Tangent is sine over cosine. Cosine of this and cosine of this is 0. So I can't say, oh, they are part of the domain. Can't do that. Okay. We can't because if I plug those in, I'm going to get 0 in the denominator, which makes it undefined. Okay. So a little bit different from sine. Sine includes those endpoints. If we look up here, see how it says less than equal, less than equal. Okay. Um, here, strict inequalities. Okay. Strictly less than, strictly less than. Okay. All right. So our domain here will be, we're not going to include them. So we're not going to use bracket. We'll use parentheses. Negative pi over 2 to pi over 2. And then the range is actually all real numbers. So from negative infinity to positive infinity. Okay, so when we look at the inverse, so here again, we have two ways to look at it. We can look at it like that, or we could use the arctan. Okay. And the inverse interchanges the domain and range. So domain is negative infinity to positive infinity. And then our range is going to be, again, we can't include negative pi over 2 and pi over 2. We have to stop short. Okay. All right. And again, this means that our answers are angles. This means answers will be angles between negative pi over 2 and pi over 2. Okay. But not including those two. Okay. Dropped my mouse. Okay. So let's do some examples here. Okay. So let's go ahead and evaluate. So these are, might be a little bit easier too, because it's going to be like sine. Okay. Evaluate without a calculator. Okay, so we're going to take a look at tangent inverse of -1, arctan square root 3. Again, tangent inverse, arctan, they mean the same thing. Okay, arctan negative square root 3 over 3, tangent inverse 0, and we'll just do one more, arctan 1. Okay. All right. So again, we can have negative angles. So sine inverse and tangent inverse, we can have negative angles, but not cosine inverse. Okay. All right. So tangent inverse. So we want to know, when is tangent -1? Well, we know it's +1 at 45 degrees, or pi over 4, right? But we want -1, so we'll do negative pi over 4. Okay. So all the positive ones are pretty straightforward. It's the negative ones. So you would do the answers that are from quadrant 4. All right, arctangent is square root 3. So that is going to be pi over 3. Again, you should have these memorized as well. So that's how I'm getting these answers. All right, arctan, negative square root 3 over 3. So that is going to be pi over 6, but from quadrant 4. So negative pi over 6. Okay. Tangent is 0 when sine is 0. So that's going to be at 0. And tangent is 1 at 45 degrees, which is pi over 4. Okay. All right. So that's how you do all of those when you're doing it without a calculator. Let's take a look at using the calculator. Make sure you can find your inverse trig function buttons. And this is pretty straightforward because the calculator already has those restrictions built in. So you just have to plug it into your calculator. Evaluate to the nearest tenth of a degree. Okay, so whenever you're doing your assignment and it says, oh, submit your answers in degrees or radians or whatever it is, make sure you're in the correct mode. Okay, so let's do that. Use correct mode. Okay, so here it's going to be degrees. Okay. All right, so try this one. Punch this into your calculator. Arcsin 0.5075 and this one. We'll do the positive and the negative. That way you can see how, oh yeah, my calculator does know how to figure out which quadrant it needs to get the angle from. All right, so make sure you're in degree form mode. So here you should have gotten 30.05 degrees. And then over here, you should have gotten negative 30.05 degrees. Okay. And same thing with cosine inverse. So again, maybe your calculator says cosine inverse, maybe it says arcsine or arc cosine. Okay, so let's use cosine, this notation, cosine inverse, and let's do positive 0.6428, and let's do the negative, and you'll see when it does the negative, it will pull an angle that is in quadrant 2. Okay, so punch these two in. For letter C, did you get 50.0 degrees? Okay, and then when you punched in letter D, you should have gotten 130.0 degrees, right? So again, it knew to pull this angle, this answer from quadrant 2. Okay, and then also do it for tangent. Make sure that you are able to get the correct answers here. 4.474, and let's do the negative as well. All right, so when you punch in the positive 4.474, you should get 77.4 degrees. And when you plug in the negative, you should get negative 77.4 degrees. Okay. Um, so for the sine inverse and tangent inverse negatives, you should get negative angles, but not for cosine. You should never get a negative. You'll get a quadrant 2 angle instead. Okay. All right. So that is the end of part 2. So stay tuned for part 3, where we do some trig and inverse trig combinations.